Okay, we have one more example for today, and that's using implicit differentiation to find dy dx when we have exponential functions. So the first problem, we're asked to apply d dx, the derivative with respect to x, to this equation x e to the y minus x squared plus 2y equals 0. Okay, and that's equal to d dx of each one of these terms by itself So some of these are easier to take the derivative of than others, and so I wanted just to break it up into pieces so we can focus on each piece. And we'll do the hardest piece first, and that's the x e to the y. So this right here is going to take a little bit of work. We have to use product rule, and then also tack on a dy dx. So this is going to be the first. So the first times the derivative of the second. Well, the derivative of e to the y is e to the y dy dx plus the second, which is e to the y, times the derivative of the first, which is just 1. Okay, so this whole thing is the product rule applied to that little bit there. Okay, and then we have the derivative of negative x squared is easy. That's just minus 2x. The derivative of 2y is going to be 2 dy dx, and then the derivative of 0 is 0. So that bit was easy too. And now what we want to do is we want to get all the dy dx's to one side, because we want to solve for that, and everything else that doesn't have a dy dx we want to put to the other side. So what I'm going to do is I'm going to subtract the e to the y. I'm going to add the 2x to the other side. So I have minus e to the y plus 2x. I move those over to the other side, and I'm left with x e to the y times dy dx and plus 2 dy dx equals, let's write it, 2x minus e to the y. Write it like that, I guess. And now what I want to do is I want to factor out the dy dx, as we do with all these implicit differentiation problems. To isolate dy dx, you probably need a factor. So you factor this and you get x e to the y plus 2 times dy dx is equal to 2x minus e to the y. So you can check that you factored correctly by multiplying in dy dx again. You should get the line right above it, which I do. And so now what you want to do is just divide both sides by the x e to the y plus 2. When it's all said and done, you get dy dx equals 2x minus e to the y all over x e to the y plus 2. And that will be the slope of your tangent line. You can just plug in any point x comma y on the curve given by that equation, and it'll give you the slope of the tangent line. Okay. Because it's a longer problem, I'll do the second problem in just a second.